All right, so what we're going to be talking about today is a library in Python that essentially lets you move data over social media channels as if basically they were a Python socket. So if you've worked with the Python internet libraries before, you basically just create an object and say, data goes in here, it comes out the other end, and you don't have to worry too much about what's going on in the middle. And that's what this does, except over a few social media platforms. So let's imagine that this is you, right? You're a super elite hacksaw. You're good at your job, good at moving data around. Of course, the standard disclaimer applies. Please use this for legitimate testing purposes, et cetera, et cetera. But nonetheless, you've got some hacking to do, right? You think you could use some more boxes. And so you go out into the world, you find yourself some hapless Gibsons, hopefully from a client that you have authorization to attack. And you use some crazy 0-day and you get code execution on them, right? And you think your job is done here. This is awesome. They're going to call back to you. But we've been finding increasingly that something like this happens, where a firewall or something, not necessarily just a firewall, there's all sorts of stuff that could sit in between you and your machines, is blocking your command and control channel. It's getting harder and harder to actually exfiltrate data from organizations, at least the ones that have put in the time and really thought about how their defenses are going to stack up against pen testers and adversaries. And so you might be trying a bunch of different things as a pen tester, right? You're trying your standard outbound HTTP, and that's just not working. So you try like maybe HTTPS, I'll get a certificate for it. And the firewall, the DLP solution is just like doesn't care at all about your HTTPS. And so you think, well, maybe I'll try it over DNS, right? Like that usually works, but in some of the really, really high level places that we run into, they're logging this kind of thing, they're keeping an eye on it, and they're blocking it. And this is starting to not work as much as it used to. And so you're like, well, maybe I'll try encoding the data in different ways. And at this point, like the firewall is just laughing at you. Like you're not able to get out. And even though you can get code execution, it doesn't matter if you can't get command and control back to you, if you can't get your data out. And so you do what what a super good hacker normally does, and you hop on Twitter, right? And this sparks an idea in your mind that maybe you could move the data over Twitter, right? I bet some of the employees in there use Twitter. Or if not, maybe they use Tumblr, or maybe they use SoundCloud, or Salesforce, or Google Docs, right? Like one of these must be used in any given organization. At least someone must be using these, especially in the case of like Salesforce and Google Docs. A lot of companies can't block these because they use them. They need them to be available. And so that's where Sneaky Creeper comes in, which is the library we're going to talk about today. Essentially, it is built like this. Where data goes in, it goes through any number of different modules that let you encode the data however you'd like. And then they go through a transfer module, we call them channels, that essentially let you move data over some sort of social media platform as if it was a socket. It lets you put data up there, pull data down on the other end, and not think too hard about the actual platform itself. So we're just going to knock straight into a demo after I show you guys one of the ideas here, one of the modules. So this is one of these encoding modules like you see here. And this is just an idea of how simple they actually are. The framework does a lot of the heavy lifting for you. So all that you really have to do as someone who wants to encrypt your data using AES is make an encode module here and a decode function here. And that's literally it. And using that, you can now encrypt your data using AES that's going over any of those platforms. It's all modular, it's all swappable. If you want to do something after encrypting, you can chain these encoder modules. So you can encrypt it and then maybe base64 encode it or something like that to make it look more innocuous and not like it's obviously encrypted. So the idea here is that the framework does a lot of the heavy lifting for you. And if you want to move data or encode it differently, it's really, really simple to just swap out something different and write a little bit of code and be moving the data in a different way that's hopefully less detectable. So we're just going to knock straight into a demo here, and we'll see how it goes. So cross your fingers here. So on the server side, this essentially just listens through right now to Google Sheets to see what's going to come out. And you see that nothing's connected right now. And we'll spin up a new client. And again, imagine that these are running on 2 different machines anywhere on the internet. And in a moment, you should see the client actually connect through to the server. And we can see that the client is actually already posted up. The server just picked them up. And then what's going to happen is that the server will actually send a command to this client immediately upon them connecting. So you can see that the client got a packet. It told us to execute a shell command and execute ls in that shell. And so that's happening right now. And let's swap over to Google Docs here to actually see it going on. So here was the initial check-in packet, A, B, and C of C. These 3 packets are actually part of the same thing. The library automatically cuts them up if they're too long to fit on Twitter. And so then this is the response, and you can see that the LS is actually getting posted right now as we speak up here. And it looks like that's complete. So let's go on over here, and in just a moment, we should see the LS output pop up over here. And this is all moving over Google Sheets, and there you are. And so this is all moving over Google Sheets. Like you can see the transmission actually happening right here, right now. So if we kill this client and then start it back up again, it actually registers in as a new client. So you'll see that there's 2 over here. You can see the post should start happening again soon, hopefully. There we go. So there's another check-in happening from the client. And then we'll see as soon as that transmission finishes up, which takes a little while. Turns out Twitter is not a super high bandwidth channel. We can go back over here and we'll see a new client check in a moment. This will have 2 clients registered. It'll send the LS again and everything will start on over. But the thing that's really cool about this is not just that we can move things over Google Docs. Don't get me wrong, that is awesome, but we're going to interrupt it because we've already seen that happen. The thing that's really cool is that we can actually go into here, and instead of Google Spreadsheets, we can do a bunch of other things. So let's take a look into the config directory and see what else we've got. So we can try all of these things. Let's try the Tumblr text channel. So we'll go in here and change it to Tumblr text, write that out.
Do people use Tumblr, Dakota?
I never have. I don't know if people do. I'm going to be totally honest.
I feel like it's maybe like 13-year-olds that use Tumblr. I don't know, because I feel like it's like totally out of my bandwidth.
As far as I know, apparently 13-year-olds and hackers now. So we're bringing Tumblr back.
That's right. Christopher Vega says, can't confirm. I am a 13-year-old girl.
All right, boom. We've got it straight from the source.
And Kate says the 13-year-old hackers are the real ones to look out for. Ooh,
yeah,
totally true.
Fair enough. So we saw that I changed literally just one thing. Like I just changed a string to tell it a different channel to use. Started everything back up. And if we go over to Tumblr now and hit refresh, you should see data start moving here. So Tumblr lets us move more data, which is cool. And you can see that a client here is connected. This got a packet. It's got the same ls command that gets automatically sent by the server. And we should see an ls come back in just a moment. Yeah, so there we are. And that was instead of Twitter moving over Tumblr with just like changing one thing. The same should work for Salesforce, although I'm going to be totally honest with you guys. I have no idea how Salesforce works. So I've been trying to find the place where these documents get uploaded, and I have no idea. So I can't actually show you the Salesforce data because I don't know where it is. It's in there somewhere.
It's in the cloud, Dakota, the cloud. That's why a cloud is part of their logo.
But the Salesforce interface is super confusing. So yeah, it is just a cloud of confusion, more like a cloud of fog. I'm going to be totally honest.
I don't know. I've never used Salesforce either.
It looks really complicated. I don't do sales, obviously, so don't really know how that's supposed to work or what exactly it does for people. But I hear it's good. Salesforce Tower in San Francisco is very big and pretty. So, and so we're just going to do, again, the same thing over again, where we can see the server here starts up. Oh, no. Oh, you know what totally happened? Okay, so here's part of the problem with Salesforce. I don't know where the data is, so I can't clean Salesforce up after I've used it. So I think what happened in the past is that we AES encrypted some data going through Salesforce, and now they're looking at this data and they're trying to decrypt it, and they're very confused because it can't be decrypted because it wasn't encrypted in the first place. Yep, that's exactly what's going on here. So
Glenn points out that it's a customer resource manager, and it's full of important data. So,
oh, neat.
Yeah.
Okay. So hopefully it is something that people or organizations aren't willing to block if they use it, because part of the idea here, especially with Salesforce and Google Docs, was you can't really block them if that's a solution that you use. Like you can't just, as a security team, decide to
well,
get rid of it.
Especially if it's cloud-based, like you have to have access to it.
Exactly. And so, if you can move your data over Google Sheets, like this. You can't just block Google and in order to keep the C2 out, which requires a lot more careful analysis, I think, which is a sort of interesting thing to try your blue teams against. Chuckling over there.
Mike says it's a spam engine. I said, well, duh, it's sales.
Oh, neat.
This coming from marketing.
Oh, yeah, okay. The rivalry is starting to play out.
I love you, sales. That's because everybody hates us, so we have to stick together.
That's fair enough. So, well, instead of doing Salesforce, I'll go through real quick here what we're actually looking at in the client. And one of the things that I think is really cool about Sneaky Creeper is that actually this is the entire Sneaky Creeper interaction, is this sending call right here. Same with, oh, we don't even receive on this one. So the actual thing that moves the data is pretty simple. The only thing that's complicated here, the only way that this is different from a socket, is that every time you call receive here, you get the entire history of the channel all at once. And so you have to have something that I call a fragment ID to make sure that you don't re-listen to old stuff. And that adds just about all the complication here. Like literally everything else is exactly like you were working with a socket. So you literally just have a while true loop here. You receive some data. You go through it all and you parse each packet individually the same way you would a regular packet received from a regular socket. And then you make a response packet here. Again, you're just sort of formatting these with these pipe delimiters, but you can use whatever you want. And then you literally just hit send on that, and off it goes over whatever social media channel you've configured it to do. So the actual this is 81 lines here, and it's a basic little implant that you could send commands to, and it will shell them out and execute them and send you the results over 4 different social media channels, and it'd be pretty easy to add more. So that's the thing that I think is really cool about this, is that in 81 lines over here and 101 lines over here, we've got a fully functioning implant and control server that can run over not just one social media channel, but several by just changing that string right there to be whatever else you're looking to send your data over.
Okay, Dakota, we have a question.
Yeah.
So maybe the audio dropped off, but someone is asking how he missed, how do you get the script planted on the client?
Yeah, so that's one of the things that is not really covered here. So that's actually a thing that's interesting to talk about, is that this script right here that you see has a bunch of dependencies. It's not really weaponized or prepared to use as an implant. Right now it'd be useful for testing. It takes a little bit of effort to set up and install the dependencies with pip and get everything ready to rock and roll. But again, the capability is all there. It's just one that isn't wrapped up in a nice little single executable package. And that's one of the things that sort of as pen testers we can, I think cheat is maybe the wrong word for it, but we can cheat a little bit in that we're not looking to necessarily always actually break into a client exactly the way an adversary would do it, but we're looking at sort of simulating them so that the blue team can catch us and the blue team can see what it would be like without necessarily having to worry about, well, we can assume that we got code execution off of phishing because we could do that, and so let's skip to step 2 because we're on a limited amount of time. So your question is really valid in that the answer is good question. There's not sort of a single way to do that. There's no good way that this is packaged up. That's one of the things that I think would maybe be interesting to think about in the future for this, is sort of integrating it into other things like potentially Empire, because it's also written in Python. But that is a long ways down the road, and that would be quite a bit of work. So a super valid question. Yeah. Awesome. I'm just watching the questions come in too.
Okay. Philip says, you want to be caught by the blue team? I thought the idea was not to be caught by the pen tests.
Oh yeah. Man, well, it goes both ways. So it's not like it's a ton of fun getting caught, but we do want the blue team to be able to get trained up and see what these attacks look like. So
I feel like that's part of why pen testing is fun, because you both want to get past them, but you feel a little bad when you do. I mean, I feel that way when I do social engineering calls. I'm like, gosh, you guys are so nice. Stop it.
Exactly. Yeah, exactly. Or, when you find a big vulnerability and you're like, oh, this is going to be so much work to fix.
I feel so sad for you.
Sorry. Yeah. It's a conflicting job.
Yeah. So Christopher has a question about your thoughts from a defender perspective. How would you suggest detections for this on a network that allows social media access?
Yeah, so that's actually a pretty good question that I don't have a comprehensive answer to. So obviously we've talked about blocking.
Sounds like a pen testing answer, Dakota.
Yeah, apparently.
It sucks.
So, as we've talked about a little bit, yeah, it's terrible. I'm sorry. So as we've talked about a little bit, like we're assuming blocking is out of the picture here. For something like Salesforce or Google Docs, that's doubly true. Twitter, you might be able to block and maybe have a minor uproar, but you probably do it. But something like Google Docs, if you use that in your organization, you can't just block that. And so the answer then becomes, I don't really know anymore. The closest I can give is doing analytics on these things. Like, again, a lot of these will beacon the same way. So you can find some of the behaviors of these. Like if something's calling out to Google Docs regularly, maybe the browser does that and maybe it doesn't. I'm not sure if there's differences in fingerprints between the way potential malware would do that and the way that that's done by legitimate applications. There's the standard detections of like, if you see Python beaconing out to Google Docs or Salesforce, maybe that's something that's a lot more concerning than a browser beaconing out. There's sort of the standard malware detections of like, oh, this is a child process of command.exe and it's beaconing out to the internet. Like, why is something that's not a browser calling to the internet? We should be concerned. But as far as like a really good answer about like, oh yes, of course, here's the solution, I really don't know. I think part of the problem here is that a lot of these services do beacon out in a like totally reliable, I'd be willing to bet Google Docs checks in with their servers like once a second very reliably. And that makes it really hard, I think, to fingerprint this from other things without using those other details like, what is this a child process of? Is it in the browser? Is it somewhere else? Is it moving a lot of data really quickly? Like maybe there's something you can do about if it's really bursty. I'm not entirely certain. I think this is an interesting area to think about. It's something I unfortunately don't have an answer to.
Christopher has an evil thought. What if the beacon is in the same time frame Google Docs auto saves? It would make the whole scenario so much worse.
I think it totally would, right? Like there's so much more evil stuff that I think could be done here that I haven't done, and I think it'd be interesting. Which I guess is the part where I kick ahead. This is all open source. It's all on GitHub. So if you want to go check it out, it is all here, right there. Which this will be shown at the end again, but get a jump start on it.
Michael has the question: are there recognizable patterns in Sneaky Creeper?
So there certainly are. Yeah. So right now, in fact, I don't know if this is still here. Here we go. So one of the things right now, the way that the packet format goes is that this is packet A of B, which essentially in this case means that this is packet 0 of 1, which means there's only one packet, and this is packet number 0. A little bit confusing, but this is the framework's way of saying that this is the only packet. And then here's the base64 encoded body. And you can see that all of these are like this, right? So especially for Tumblr, which lets us post pretty long text, you'll usually only get one packet at a time. And so right now what you'll see is this little framework where you're like a letter and then a space, and a letter and then a space, and then the body of it. In fact, if we go back over here to Google Sheets, which I shouldn't have deleted, we can see the way that those packets write out. Oh no, I put the wrong thing in.
Oh, the live demo.
It is Google Spread. Oh, of course. Okay, so try and talk and type at the same time, which is inevitably going to go disastrously. Yeah, there are totally patterns in this right now. I think that's one of the things that, like, there definitely don't have to be patterns. I think that's something that could be fixable, but again, fixable air quotes from an attacker's perspective. But right now there definitely are. I don't know how robust those indicators will be, either for the framework itself changing or just for in general social media C2. But certainly at least in the iteration right now. So you can see here, this is packet A of C, B of C, and then that packet was over. So whatever it was sending here was too long to fit into one tweet. So if we actually go back to here, you'll see like a whole bunch of tweets rolling, I think. Oh no. So this was too long to fit into one. Wait, what am I talking about? This is over Google Sheets. Anyway, so this was too long to fit into one cell, so it got split up into two. Again, that's done automatically on the back end by the framework. Whatever the channel is, doesn't have to worry about that. And so you can see that there's A of C and B of C, and then here A of B, and then this is L. So this is, I think, the output of the LS, so it's quite a bit longer. So this has to keep going, and then we should see, I think, one more come in. Yep, and that's the end right there. So certainly as it exists right now, there's these indicators where you can fingerprint off of these, but that's something that I don't know that you could rely upon for very long. I think that could just get wrapped into the rest of this and pulled down on the other side. So as we saw in this diagram right now, what happens is that it gets encoded, and then that thing where it puts the little packet headers in there happens here after the encoding. I think that could definitely be moved to somewhere where it all gets wrapped up in the encoding, and so you don't have that indicator anymore. It's just, that's how it is for right now. I think it's not something I would rely on.
So there's a good question, and I don't know if you know the answer to this, but I feel like you might. Michael asks, so from a beaconing standpoint, do you think this is something AI Hunter would pick up fairly easily, like packet size, frequency, etc.?
I think it would. I haven't played with AI Hunter overly much, but from what I've seen,
I feel a part two brewing.
I think it probably would. Yeah, that'd be really interesting. Now I want to try this out against it. Because again, it is the same beaconing behavior, right? So the way that this works in the code is that it's, oh, I'll have to kill that off. So if you go into the code here, the way that it's doing this essentially is that, this one's less beacony, but it does an initial check-in, and then it just checks constantly. Like it calls receive, and then it just deals with whatever that is and sends any responses. And the framework actually handles rate limiting for you too. So you just hit send as often as you want, and it will keep things from sending if that send is not going to make it, because you're going to get blocked by rate limiting. It's not very robust right now, but it does something to keep it in there. So what you should see is no matter what you do here with t.send, it should come out at most at a very set frequency based on the rate limiting. And so I think that would be something AI Hunt would probably pick up. The bigger question is, how different does that look from your regular beaconing, which for like Twitter, I don't think really anything should be beaconing regularly to Twitter. That'd be a huge red flag. Whereas with Salesforce or Google Docs, maybe things beacon there legitimately. I'm not entirely certain. That would be really interesting.
Wouldn't the save be a beacon?
Yeah, I think it might. I haven't really looked into what Google Docs like network traffic looks like during legitimate use. I'm really curious now.
Curious. Mike asks, can you set the user agent used?
I don't actually think we can right now, but that would be a very good thing to fix.
Dang, we're like, these are all leading us to even more great webcasts, you guys. Good questions.
Yeah, here we go. Yeah, I don't think the user agent gets set right now. I think it's probably just the Python default user agent, but that would be really interesting to have a way to set that in to be able to handle this better.
And Chris asks, would this be the sort of thing an insider threat would use? Would this get past a DLP solution?
I think it would probably get past DLP right now, if for no other reason. Again, this is obviously super dependent on what your DLP solution is and how it's set up, and like a million other caveats besides. But to be totally honest, in my experience at least, a lot of stuff doesn't, right? Like it's hard to look into every single packet leaving the network, put every single packet together into a full, like comprehensive view of what's actually the data in that set of packets, and then inspect that data and be able to intelligently, like as a machine, say, oh yeah, this should not be leaving. So we found that, you know, sometimes we'll get caught if we're doing, like, if you just email credit card numbers out, we'll get caught, right? But then if you like put those credit card numbers in an encrypted zip file, you don't get caught anymore. Things like that, where it's just, how do you can't decrypt the zip file. Do you just assume that everything encrypted is illegitimate? At which point, like, there must be applications that either send things encrypted or send things that are like encoded in such a way that they look encrypted. Now those don't work. I don't know how much I'd be worried about an insider threat doing literally this versus just like emailing things to themselves or logging into you know, Tumblr manually and just posting things there, or throwing things in their Dropbox and having them sync out that way. I think that's a good concern. Like an insider threat would be a serious problem that would use a lot of stuff like this, but I'm not sure they'd use literally this tool. I think you'd use the same techniques by just manually logging in, to be totally honest.
Because that would be way easier.
Yeah. Than trying to get this all rigged up when you could just, you know, log into
Post it.
Yeah, log into Google Drive and upload your stuff and go home and like sync down there. And then that raises the other question of like, that is legitimate use in a sense. That's totally what Google Drive is intended for. So how do you deal with that? Wow, I have no idea.
Yeah, but the kinds of things you can do when you like are on the inside are horrifying. I mean, the amount that you have to trust your employees and your everyone in your office, just so sad. Blue team, I feel for you so bad.
Yeah. Oh man. Yeah. If anyone figures out like the solution to insider threats, you know, that'd be great.
Philippe asks another question. He says, sorry, I missed the beginning, so maybe this isn't appropriate, but why not use DNS channeling with reflection using the inside DNS server to do your beaconing?
Yeah, I think that's a totally legitimate technique, and it's one that we find works almost all the time. It still works really well, but I think it's starting to get to the point where people are paying attention. Sorry. I think it's starting to get to the point where people are paying attention. And this is sort of, I like to think anyway, the next step beyond that. But yeah, no, that is totally legitimate. The DNS beaconing, especially using like an inside server so it gets relayed onto the outside, works super well. I know for example, AI Hunter keeps an eye on DNS, and I think it does a really cool and really good job of noticing a lot of DNS requests to places that maybe shouldn't be getting a lot of DNS requests. But you know, I think that's still kind of the edge of things. You know, if we see an organization that has DNS logging and really pays attention to it, that is pretty rare and impressive at this point, as far as from what I've seen. And so I think this technique that still works really well, still works most of the time, but you know, every once in a while you hit a place that is paying attention, and I think more and more of them are going to in the future.
Hopefully.
Awesome. Yeah.
We're all getting better. Michael has the question, where do you set the credentials for Google Docs, Twitter, etc. in the config files?
Yeah, so here, I'll actually just print one of the config files. Let's print out, man, which is one that I'm okay just printing out for all of you. Okay, so we'll just print out the file config. It's essentially just this. So you can totally set it in the code. It's gone, but you can totally set it in the code there. But I just put it in a bunch of files because then I can just do that one string change and it picks up a new file, and it looks way more impressive than me copy pasting in a new set of config. But essentially the way that works, here, I'll kill this off. Essentially the way that this works is it opens up the config file, you know, it's JSON, it reads it in, and then loads that up into a Python dictionary, and then you just pass the parameters in, like set encoder params, set channel params, and then you set them for sending and for receiving. So like for one of the things you could do if you wanted to was you could have a different AES key. Sorry, you could have a different AES key in one direction than the other. Not entirely certain why you would do that, but like maybe it'll make people's lives harder if they're trying to do incident response on it. Who knows? So yeah, you can actually see the AES params here, where literally all you have to set is a key. This one's a really lame key, and then you just set them for sending and receiving. Same sort of deal here. So this is sort of like the easiest possible use of this, where you create this little exfiltration channel. You can sort of treat this like a socket. You set the params. So this just uses the file, which literally just creates a file called test.txt and uses it as if it were moving it over the internet. And then you can set the encoder params. So in this case, you use base64. And then none of this is even necessary. Like this just prints the thing. And then this is send, this is receive. So theoretically, if you wanted, like a bare minimum here would be that. And you can now, send data over a bunch of different platforms. That's the bare minimum right there. Which I think is pretty cool. Like 18 lines of Python. Honestly, you could get rid of even some more of these if you cut it down. Less than 20 lines of Python, and you're moving things over. Twitter, Tumblr, Salesforce. I think that's cool. I'm also
Dakota, why you gotta be so scary?
It's a way of life here at Black Hill.
That's right.
We do our best to be very scary. Not really. We're not that scary. We're very nice people, mostly.
Mostly. Most of the time, we're super awesome.
Yeah, exactly.
All the time, we're super awesome. Most of the time, we're super nice.
There you go. So here's all the stuff that we can move it over. SoundCloud is a special case here. I didn't show it to you because we have a module that totally works for it. It was written, I think, like 2 years ago. And it works. You can move data over SoundCloud, but SoundCloud is like, I think, going bankrupt or something right now. Things are not awesome over there as far as I can tell. So you can't get API keys for them anymore. If you have an old one, apparently it still works, but you can't get new ones as of the last time I checked. So we have a thing that moves data over SoundCloud. It actually encodes the data into a WAV file and then uploads that WAV file to SoundCloud and then does the reverse on the other side. If you try to listen to the audio, it is horrible screeching. Don't do that. But it does, it's a legitimately formatted audio file with a bunch of data.
Crazy.
So if anyone knows of anything like SoundCloud that lets you upload audio files that won't be compressed or encoded because that will destroy the data in them, let me know, because we could probably just reuse this code for somewhere else. Like anywhere that we can upload a WAV file and download it on the other side and it's still in its original form, we can reuse this code. If you know one, let me know.
Oh man, Philip is asking for an example. I don't think so. The screechy non-music sound.
God, no. I refuse. It's really rough. It's really, really rough. One of the things that we've been meaning to do is, the code. The way the code works is that it just generates totally random audio, and then it actually steganographically encodes the data into the least significant bits of it. So if we took like a real actual sound that wasn't horrible screeching, I think it would sound roughly the same with our data in it. But we haven't actually put anything in here to use an existing audio file or generate one that isn't terrible or anything like that. We figured by the time someone is realized that something's up here and is listening to our audio,
it's too late.
They're not going to be like, wow, this is really suspicious that it's beaconing out, and then go to SoundCloud, open up one of the files that is uploaded and be like, oh wait, this is actually pretty pleasant. Never mind, I'll leave that in place. We figured by the time someone's listening to our audio, you're already caught. Yeah.
So speaking of steganography, you wrote a blog post about that, right? Remember that? It was a while ago.
I do remember. Oh, look, it's still in my.
Somebody's asking, could you do this in a JPEG?
Yeah, so that's actually a really interesting one. I think the way that I've done steganography in the past, which if you want to know about that,
he wrote a bunch of blog posts.
Multi-part blog post. But this image right here has, I think 10K of data in it, something like that. It's actually got some steganographically encoded data in it. I forget what the message is. It's something. If you decrypt these Easter egg, there's actual words in there. I forget what they are, so hopefully it's nothing awful. Anyway, so the way that I did it here was actually hidden in bitmap, because bitmap is pretty easy. It doesn't get messed with. This is literally the bitmap format. There's a little R, G, and B channel in each pixel. It's pretty easy to put data in and out. It's not too much trouble. And this is actually one of my favorite pictures. You can see here the 8 significant bits. So this is the least significant bit. And you can see it's basically just noise. Changing this one and this one doesn't really change the picture significantly. So this one actually, I think this is the original, and then this one has all its least significant bits flipped to 1. and you can see they're basically the same. And then this one has, I think this is not the original. This is all the least significant bits. This is the least 2 significant bits. You can start to see a little bit there. And this is at least 3, which starts getting obvious, and then it pretty quickly degrades after that. Anyway, to get back to your actual question, yeah, you could totally do this in images. JPEGs I've had trouble with because they compress. They do some actually really cool like compression algorithms that are sort of built into the JPEG standard that are troublesome to work with. There are totally ways to do it. I have not played with them, but in bitmaps, yeah, totally. Bitmaps are pretty easy. And you could put something up to, I don't know what image hosting places don't compress your images. Compression is sort of the enemy of steganography. If you get compressed, on the one hand, it doesn't matter if you throw this out, which is why compression works, because you can just throw like these 2 out and the image looks the same, but you've saved all that data. But if you throw that out and that's where our message is, then we're very sad. Your image is smaller, it's compressed now, but it's compressed because you threw out our message that we were trying to move. So anyway, long answer is you should read this article because I think it's good.
Because it's awesome.
Oh, thank you.
Actually, Dakota hasn't written a blog post in a while, so.
That's true. That is true.
Don't think you're on the hook because you got a webcast. Just kidding. Just kidding.
Yeah, all right. Marketing is a slave driver around here.
I know. Marketing's terrible. Chris says that stagsolve.jar is a great tool to illustrate this.
Ooh, okay.
You guys want to check that out.
Cool. Okay. It looks like there we are probably.
FYI.
Neat. Okay.
What are hapless Gibsons? Somebody.
Oh, okay. So if you've seen Hackers, the movie, which you should, it's awesome.
I haven't. I should probably watch it.
There's a computer in it called the Gibson. Yeah, here you go, hacking the Gibson. I'm not going to play the clip for you, but it's a great. Well, it's an awful movie, but it's great because it's awful.
It's a B classic.
Yeah, well, B is generous, but I love Hackers very much. That was an obtuse reference to the movie Hackers, which is great.
Actually, no, that wasn't a question I asked, Phil. It was a question someone else asked. So not everybody is in the loop as Dakota and the rest of you. Some of us are still noobs here. So I'm glad. It's good, though. It's good because sometimes I feel like I don't have any idea what's going on, but it's good. I can be like the lowest level, and you guys are all like from here to Dakota between me. So
cultural
there's
reference
room for everybody here.
Yeah. Everyone's welcome. These webcasts are for everybody.
That's right.
Hopefully you get something out of it, no matter who you are.
I learned the things.
Boom. So as far as like the future of this, I know we've talked about this a little bit and fragmented, but I did make a slide for it, so it's here in one place. One of the things we talked about, like someone was asking about bitmap, it would be really cool to have file encoders. So like I mentioned right now, the way that the audio works with SoundCloud is the code that actually posts things to SoundCloud also does the work of formatting a string into audio. And it'd be pretty neat to have that separated out so that if you wanted to write something that used audio somewhere else, like you found a different service that lets you upload audio, you could literally just in your module, like we looked at how simple the encoder is earlier, right? Where it literally just gets some data and then returns it encoded, and that's all we want from it. It would be really neat if we could do that as well, except you could indicate in here, hey, the output, like whatever you hand me needs to be an audio file or needs to be an image. And that way you don't have to worry about encoding the data that you get into an image because it's just done for you and we wrote that code once and it's reusable and you could use it in a bunch of other places. And that'd be super neat. Again, like we talked about earlier, more complete encoding or something malleable would be really awesome. Again, like someone asked the question, is this detectable? And the answer right now is heck yeah, totally, because you can see that it has these packet formats. But I think it would be not too hard to just put the encoding around all of this so the packet formats aren't there anymore. That'd be a cool thing to work on. In addition, of course, always more channels and encoders. There's like a million places probably that was meant to be an exaggeration, but it's probably literally true that there are millions of places on the internet that you can like put data and then pull it down on the other side, right? Like there's no pastebin channel yet. I bet that would be mega easy, et cetera, et cetera. Like there's always more channels and encoders we could do. One thing that I really want to try I saw this like a couple years ago. There we go. I saw this like a couple years ago at, I think, DEF CON, where essentially you can just take this, there's a library here that lets you take data and then it just spits it out as a whole bunch of like different things. So you can choose to encode it as amphibians, as desserts, as like a whole bunch of other random words. That's not any bigger. And essentially what it does is here we go. So you basically put data in and it spits them out as like status codes. And then on the other end, it'll take those back in, convert them back to the data. Like you can emoji even, right? Like, and so what you do is you take this data and you put it in and it comes back out as like a list of emoji. And on the other end, you put in a list of emoji and your data comes back out. And in the middle, like your data loss solution or whatever just sees some emoji, which of course is totally legitimate. No one should ever block emoji.
That's right.
Yeah, workplace productivity would plummet. Anyway, so you can do things like that, and I think it'd be really cool to include those as encoders. Again, like I showed you earlier, you literally just need to write two functions, one that puts the data into whatever the encoding format is and one that takes it out. And I don't think it would be too rough to just include things like this. Like this even is in Python. So of course, there's always more work to be done there to get around stuff. And then someone also asked, how do you get this on a box? And the answer is, yeah, that's a really good question. Right now, there's a lot of dependencies on this. Installing it is kind of a pain. And like I showed you, that all it can do right now is just sort of run shell commands and return you the output. You can't really like upload data or anything, not super well. So like maybe there's integration with existing tools there, or maybe there's a better implant that we could write on the other end of that communications channel. Right now, it's at least in my mind, I kind of like that it's not super weaponized because, like we talked about, I don't really know of a good way to defend against this super well. And so right now the defense is it's a bunch of work to get it into a format that's really usable in any meaningful way. And like, if anyone's willing to go to that much work, they were probably going to cause trouble anyway, and there's nothing we can do about it.
They're after you.
Yeah, exactly. As far as me working on this, we're working on some cool internal stuff here at VHS that I can't really talk about, but it uses some of the lessons I've learned from this, and it will probably be occupying a lot of my energy in the near future. So I'm not sure how much time I'll be able to put into this, but like I mentioned, it's open source. It's up on GitHub. If you want to submit pull requests, I will keep an eye on those. It's already been forked and starred enough times that I'm sure there are other people out there using it. It'd be pretty cool to see it used more, as always. And if you want to hear about this, I don't think we can really talk about it, but you can always try. There's a contact form on the website. And, if I'm sure this will get used in our engagements starting probably in the nearish future. So there's always that sales pitch.
It definitely would be cool to see it with AI Hunter. So
that would be really cool. I think that'll be something I'll be playing around with. I'll talk to someone to see if I can get a copy of that set up. Because I'd be really interested to see what the fingerprint actually looks like from a defensive tool like AI Hunter.
And if you guys do want to play with it and come up with something cool or find something and you want to write a guest blog post,
true.
So we try to have like a really active blog and also make it open for other people that want to submit cool stuff that they find. So that's amazing. So yeah.
Cool. Before we finish up, I just want to give a big shout out and thank you to all the other people who've worked on this. I'm not the only person who's contributed to this project. So big thank you to all these folks for writing some code that you saw running today. And with that, thank you very much. I know we've been doing questions along, but if you guys have more questions, that would be awesome.
We did have a couple that I didn't ask you yet. Steve said, is the code proxy aware? I don't know if you answered that, but
I don't believe it is. Along the same lines as the user agent, I think there's some. In fact, I think there's literally a GitHub issue open for like proxy awareness. Yeah, open in 2015. So that's good. That's real good. Yeah. Proxy awareness is not good. Right now, I think something like proxy chains is maybe the best way to go, where you're sort of forcing it through a proxy externally. But yeah, in the same vein as like this sort of weaponization problem, yeah, there's definitely a lot of work to be done there before this is like a fully featured, implant that I would use on an engagement. Right now, it's just sort of a proof of concept tool.
Cool. Christopher E asks how many Chris or Christophers are on this, but it might be the best webcast audience ever. Yes, I agree. You guys are really awesome. And I love how engaged you guys are and asking questions. And I love that the live webcast can be kind of its own thing with you guys.
Makes it way more fun to be on the webcast where there's people like interacting rather than just I'm like talking and it's silent and I'm sad.
I hate that. And it's also a lot more boring when you're attending those kind of webcasts. So Christopher Vega says I'm the best one ever. So sorry, other Christopher. But we are super happy. I am sort of always surprised how many people have the same name, but there's like 200 people on. So I guess it was.
I suppose, yeah.
So. Thanks for coming, guys. You've been an awesome audience. Dakota, you've done a great job. I definitely will hit you up again for more webcast material. Hopefully you liked doing this the first time.
Yeah, it's a good time.
And I always have a lot of fun with you guys. And so everyone says thanks for the awesome webcast that you did a great job.
Everybody showing up.
Yeah, it was amazing. We love you guys.
Everybody loves John.
Bye-bye.
Bye.